Hello guys, welcome to another video. In this video, we would be seeing about views in Snowflake. We'll discuss all the different types of views which Snowflake provides, okay? And let's keep it fast and simple because we all know about views, and being a data engineer, we will for sure know about views. Let's first see the practical implementation of the views, and then let's cover up all the points in the slides. So if you come here, I'm just creating a database and I just create this schema. And I'm just using this particular schema for my tutorial. Okay, if you see, we can just create a table, right? I'm just creating a simple table out of the data from another database which Snowflake provides, and that's it. If you see, I'm able to read the data from my table. Now we know we do create views from the table by applying some SQL query. We know that view will never store the data. We will just, whenever you refer to the view will just execute the underneath SQL and provide the results and store it in this particular view. So it doesn't have any physical storage. That's the purpose of the view, right? So if you see, now I'm just creating a view using creator replace view name as SQL query, any kind of SQL query. So out of the table, why do we create view? To filter out the data and have only some kind of records, or for some security purpose the table will have all the personal or PII information, and the view, in the view will be hashing that kind of information, and we provide access to the view only for our team. There are multiple scenarios. So this is how we create the view, like in every database. This is how we create the view even in Snowflake as well. So we can just query the view, that's it. So now if you see here, I just have only the building segment information only, but this particular table has other segments as well, building, household, and many other. So now if you see, there are different types of views in Snowflake. Like one is non-materialized view, which is a normal view in any database. Which doesn't store the data underneath. Whenever you refer to the view, then the underneath SQL gets executed. And then is a materialized view in which the data is physically stored, and we'll discuss about materialized view. And the third one is secure view. So the secure view is used for the security purpose. Like for suppose if you don't want to reveal the view DDL to your team, then you can go with the secure view. Using the secure view, we can't view the DDL. And the second thing is like, so if you see here right now in my view, I just created with the segment as building, but in my table I have another segment type called household as well. So when I try to query the normal view, they say like we'll be getting an error, which I did not get. So this normal view is also acting like a secured view only. Might be I might have missed something, but I'm just trying to explain that as per the documentation, they say when you query the normal view to find out the records which doesn't satisfy your filter condition, because the views are created with some filter condition, right? When you try to query the view to find out the records which doesn't satisfy your condition, it might throw an error. That's why we have to go with the secure view. And if it throws error, that means that there are some other data as well. The people who are accessing the view will understand that there is other kind of data as well, right? So that's why they say like go to the secured view and you will not get any error. But I did not get any error even for the normal view as well. I'm just trying to say that, that's it. And now if you see, in case if you want to know whether your view is secure or not, you can query this information schema dot views, and you'll get to know the whether it's a secure view or not. My view is not a secure. There's another column which says if it is a secure view or not. That's it. Now to create a secure view, you can just add the secure here. You can create a secure view, normal or non-materialized secure view, or you can create a materialized secure view as well, just to add a secured keyword. That's it. Now if you see, I'm just creating a secured view, and I'm just trying to execute this particular SQL, the same information schema dot views. Now it's a secured view. That's it. Now if you see, the same condition which I have tried to execute above, I'm just trying here again, but it's not throwing an error even in the normal view, even in the secured view. So this particular point I'm not able to understand what is the difference from the documentation, but in the documentation they say we'll be getting an error in the normal view, which I did not get in the normal view as well. I just tried to, in case if it's confusing, I just tried to explain the same scenario again. If you see, I have a table called widgets, and I have these particular 3 rows, and I am creating a view with just red alone. That means these 2 records alone should be there in my view. This is just a normal view. See, there is no secure view. But they say that when you try to query this particular view, okay, to find out whether there are any records other than the color equal to red. That means I'm just trying to filter out purple. It should throw an error, but it did not throw an error, the normal view also. But they say it should throw an error in the documentation. That's why go with the secured view is what they suggest. But the normal view and the secured view behave the same for me. And another pointer is like secured view, you can't get the DDL so that people will not know the structure of the table. That's it. Now let's see on how to create a materialized view as well. Okay. So now I'm just creating a normal table. That's it. Now I am creating a materialized view. Here create or replace, instead of view I just give materialized view, and I'm just writing the SQL logic. That's it. And to highlight before going to the PPT, materialized views are like mini tables where they store the data under it. Normal views will not store the data in that view. Materialized view will store the data. Normal views, when we point out that particular view, they execute the underneath SQL and then get the data. But materialized views will store the data. So now this particular view is created from this table called inventory. So I just created this particular view. So now if you see, when I try to insert the data into the table, the view get refreshed and the view is also updated. If you see here, I just created one insert here, and now when I try to query that view, I should get this particular row 1 1. See, I got this particular row because I created only with these two columns only with the view, only these two columns. That's it. So immediately the refresh happens, and it's being handled by Snowflake internally. We don't need to bother about the refreshing of the view. And when to go with the materialized views when we have the tables and all is like when you have some complex logics which you need to calculate from the table, then you can create the materialized view on top of table where you calculate some windowing functions or some aggregation operations, some kind of time taking analytical sequence. If you have, then you can create a materialized view out of the table. That's one scenario. And second thing, in case if you have some external tables, querying an external table is slow, right? So if you create an materialized view from an external table, it will be quick. So we can access that materialized view and we get the data so quick. So there are few scenarios which we will see in the slides again. So now even using materialized views, we can join with the normal tables and with the other views and everything. If you see, I just created a table called sales and I inserted the data. Now if you see, I am just joining your materialized view with this sales table. That's it. This can also be done, and I'm creating a view out of it. Like using the materialized view and a table, I'm creating another view. They can be used however you want. That's it. So now there is another option in materialized view which we saw, that materialized are auto refreshed whenever the underneath table is getting the data, right? Auto refreshed. If you want, you can suspend that as well. But the problem is, if you suspend the materialized view, you can never use the view which has referred to that materialized view as well. So if now I have suspended, so now if I try to query that materialized view, I'll be getting an error. Now if you see, I have an inventory table. Okay, this particular inventory table, I'm just trying to insert one row here. Okay, now I have sales table, I'm just trying to insert two rows here. That's done. But if you see, this is profits. What is profits? Profits is a view which uses my materialized view as well as another sales table. Now if you see, when I try to query, we'll get an error because this particular view is using materialized view underneath here, MV1. That's why we get an error. So to make it work, again we have to resume. When you resume and when you query MV1, because if you see, we have inserted one more row, right? As we resumed, immediately it should refresh. See, we got the two rows. That's it. And the same should work for the profits table also. Immediately it should be refreshed and we should be able to query. The second row has come up. That's it. So this is how we use the materialized views. You understood? We can pause the refreshing of the materialized views, or we can resume that as well. Materialized views will store the data underneath. Normal views will not. Now the second thing is clustering, but the clustering will come after going through the PPT. I believe first we'll look into the PPT. So now views. So now if you see the definition of the view, a view is a saved SQL query that acts like a table. Like from the table, you can create a view by applying some SQL logic, like by adding some filter or by joining with other table, so that we can refer to that view alone. We don't have to write the SQL logic every time. Or in case if you want to hide some I majorly used views for the PI columns, like there can be customer address, customer mobile number, email address. In the table they will be stored as it is values, but in the views they will be hashed. We can use UDFs and hash that particular columns alone and create a view, and every other team will use that particular view only. They will not have access to the tables. And if you see the types of views, there are non-materialized views, which is normal views, and next is materialized, and then is secure views. These are the three views. Now if you see, let's go and see the secured views. As I said, the secured views are special types of views to keep the sensitive information hidden. Okay. If you see, as I mentioned, they protect both the underlying data and the view as defined. I mean the SQL query as well. Everything, the view definition and everything will be hidden in the secured views. And the major purpose which Snowflake documentation highlights is, like, if you use the normal views, you can even try to fetch the data apart from the filter condition which we have in the view SQL code. But it didn't work for me. That's what I have shown you as well. It did not throw an error. So the secured views and the normal views behaved the same for me. And to create a secured view, we just have to add the keyword called secure, and you can convert the normal view into secured view using alter view command. That's it. And as I said, like, we can use this information schema and understand whether this particular view is a secure view or a normal view as well. And you can use like role level security with the roles. Like we know, right? In the data warehouses, we have, every user will have a role, and based on that role, we can make sure that this particular user, these particular roles will have access to these rows only. That kind of things can also be done. And the second thing is materialized view. Like materialized view is used like in case if you have some complex queries or pre-computed results, in case if you want to access quickly. If you see, instead of calculating the results every time you run a query, Snowflake computes the result once and then reuses that data. Snowflake will automatically refresh, which we have seen, right? So some kind of aggregation operations, in case if you want to store in a separate way, in case if you want to store these aggregation operations or complex logics, so that every time when you don't have to calculate them and get the latency, that times we have to go with the materialized views. And when to create materialized view, like in case if you don't want, like let's assume we have a very large table and we don't want to query the table every time, so you can create a smaller view or a smaller materialized view out of that bigger table. And in case if you have some expensive calculations, or in case if you have some external table, because querying external tables is very slow. That's it. Like in case if your source table is kind of updating every minute or second, it is preferred not to go with the materialized view only. It's updating like daily, something like that. Then you can go with the materialized views. And the advantage of materialized views are the speed, automatic maintenance, the transparency. We saw the automatic maintenance, like whenever the source table is updated, the view is also immediately updated. And we know, right, like we can create the view using this particular statement, and we can suspend or resume the materialized view as well. We saw that. Now the next thing is clustering keys on materialized views. We know in Snowflake we can cluster the table as well. And now you can ask, what is the purpose of clustering again on the view? Let's assume we have a table and it is clustered on column A. Now we can create materialized view. Let's assume the source table has like 20 columns, and we can create a materialized view with only 6 columns. And in these 6 columns, we might not select that clustered column, so we can use another column to cluster. So literally we are clustering here 2 columns, one on the table and second on the materialized view. So when you fetch data based on the column which is clustered, then we can directly point out to the view and get the results faster, right? That's one use case. Use alter command to add the clustering key. Now we understand the major purpose of clustering in materialized view. If you see here, that's what we have discussed this point, different clustering columns. You can choose different clustering columns for a materialized view than for its base table. For instance, even if your base table is clustered on customer ID, your materialized view might be clustered on sales date, some other different column. So for suppose we don't give access to specific set of teams to our tables, and we are giving access only to the views, then the views should also be clustered. Then only the queries will run quicker, right? So that time also it will be helpful, as we are giving access to the views, and if the views are clustered, the queries when we query on that particular table will be quicker. And the major thing is like time travel is being disabled in views. We can't go time travel with the materialized views. However, we can't do with the non-materialized views because they just execute the SQL underneath, that's it. But as the materialized view stores the data, we can't do time travel, and which is limited only to the tables in Snowflake. And now cloning support, when you clone the database and all, the views or the materialized views underneath will also be cloned. That's it. Now let's go and check the clustering once. If you see, I have a table called pipeline segments. Now I am inserting two rows here. That's it. Now I have another table called pipeline pressures. I am inserting another two rows here. Now we are creating a materialized view with these three columns from this pipeline segment table with some where condition. That's how we create the materialized view, right? We'll have some SQL underneath. Now, if you see, I am just altering this particular view which we have created to make sure that my materialized view has been clustered on this installation here. So when we query on this installation here, we get the results faster. That's it. So we can just query the materialized view. That's it. So this is how we create the clustering. The purpose of showing this particular execution is to show that this is how we will have to add clustering on materialized views. We have to use an alter command. Unlike the table DDL where we can cluster on the DDL for a table, right? Here we have to use alter command on the materialized views to cluster on a specific column. That's it. That is about the views in Snowflake. Thank you so much for watching.